Okay, let me start explaining the concept of operations on whole numbers. Right? You know what exactly the whole number is, right? See, whole number is nothing but all natural number together with zero are called whole numbers, right? See, without a zero, it is called as natural numbers. You have learned a different kind of numbers in the previous topic, right? Here you are going to more concentrate on operations on whole number. Before entering to the operations of whole number, so we should know what exactly the whole number is. Whole number is 1 with 0. It's a natural number. Together with 0 is called as whole number. It is denoted by W and it is represented like this. That is 0, 1, 2, 3, 4, 5 and so on. It is called as whole number. If it is not 0, 0 is not there, then automatically it is called as natural number. Right. So let us understand some different kind of operations performed on whole numbers. So the basic operations we are going to do with this whole number is one is addition, second one is subtraction, third one is multiplication and fourth one division. We are going to learn the different properties of addition and other operations like subtraction, multiplication and as well as for division also, right? So let us check out with that. Addition. Addition basically represent the idea of finding a total count of values. Say for example, see you can take anything. See here only I am going to show you. So for example, this is 5 plus 8 plus 3 is equal to 16. 8 plus 5 is 13, 13 plus 3 is 16. Or otherwise, you can take this also, that is 15 plus 16 plus 21. So 1 plus 6 is 7, 7 plus 5 is 2, right? 1 carry, right? 2 plus 1, 3, 3 plus 1 is 4, 4 plus 1 is 5. This is nothing but addition, right? It is represents the idea of finding a total count values. You are going to count, that's it, right? There are different kind of properties of addition. So one is commutative property. So addition of whole number is commutative. What is commutative? See, let us check out. If A and B any two whole numbers, then A plus B is equal to B plus A. That is A plus B is equal to B plus A. So irrespective of the position of the numbers, the sum will be same. Say for example, 4 plus 2 is equal to 6, which is nothing but 2 plus 4. Right? Or otherwise, 6 plus 8 is equal to 14, right? So which is nothing but 8 plus 6. The respective you can add, you can take the 6 at the beginning and as well as add to the 8, or otherwise take 8 at the first and then add to 6. The answer will be same. This is called as the commutative property. Right. So next one is associative property. What is associative property? See, you can check out here. How exactly it works? Suppose if A plus B plus C is equal to A plus B plus C. Right. Say for example, 4 plus 2 plus 3 is nothing but 4 plus 2 plus 3. See now see here, it is 4 plus 2 first I will add, that is going to become 6 plus 3, then you are going to add, that will become 9. Here in this right side what I am going to do, 4 I will keep as it is. So 3 plus 2 I will add first, that is 5. So then I will add to the 4, that is also 9. See, this is nothing but associative property. These properties are going to be used for some kind of problems that I will show you. Next is properties of addition. That is additive identity. The whole number remains unchanged when added to 0. 0 is called as identity element, right? 0 is called as identity element. Example, whatever you are going to add, you see to the 0, whatever the number you are going to add to the 0, the remaining it is not going to change at all. Say for example, 3 plus 0 is equal to 3 or 0 plus 3 is equal to 3, right? Or otherwise 3 plus 7 plus 0 is equal to 7 only. It is not at all going to change if you add to 0. Or otherwise 10 plus 0 is equal to 10 only. This is additive identity. There are three other properties will be there for addition. So now let us consider the subtraction. Subtraction is nothing but it is a reverse process of addition. It's a reverse process of addition. So you take an example of this. See, 8 plus 6 is equal to 14. Right? 8 plus 6 is equal to 14. There are two associated subtraction statements will be there. This can be 14 minus 8 is equal to 6 or 14 minus 6 is equal to 8. See, the subtraction is not commutative, not associative, and not identity property for subtraction. Anything is not, it is not there any properties at all here. So a minus b is not equal to b minus a. That is, say for example, so 8 minus 6 is not at all equal to 6 minus 8. See, 8 minus 6, what happens? 8 minus 6 is equal to 2. But see here, 6 minus 8 is equal to minus 2, which is not same. Right. Similarly, the associative and as well as, see, a minus 0. Say for example, 7 minus 0 is equal to 7. But 0 minus 7 is not is equal to 7. It is going to become a negative number. So that's what there is no property involved in subtraction. Right. So let us take multiplication. Multiplication of whole numbers represent the idea of repeated addition. It is nothing but a repetitive addition only. Say for example, if you take 3 into 4 is equal to 12. You know that. So now what happens here? It means we are multiplying. So we are adding 3 4 times. That is 3 plus 3 plus 3 plus 3. Which is nothing but 12. See here, repetitive addition of the same number. Or otherwise, if you take 4 into 3, which is nothing but we are adding 4 3 times. That is 4 plus 4 plus 4, which again gives you 12 only. So this means it is a repetitive addition only. Here there are different kind of properties also involved with the multiplication. Let us check that. The product of two whole numbers is again a whole number. Suppose if you multiply 4 into 3, that is 4 into 3 is nothing but 12. 12 is also a whole number. That is closure property. This property is called as closure property. Or otherwise, 12 into 8. 12 8s are 96. This is also a whole number. This means the product of two whole numbers. This 12 is also a whole number. 8 is also a whole number. So automatically when you multiply the two whole number, the product is also a whole number. Fine. See the next property is commutative property. The multiplication of whole number is commutative, which means it is just like addition. See, in case of addition, what happens? A plus B is equal to B plus A. Similarly, here in case of multiplication, A into B is equal to B into A. That means, say 3 into 4 is nothing but 4 into 3. 3 into 4 is 12, right? And as well as 4 into 3 is 12. This is commutative property of multiplication, right? Associative property. Let us check. Let us consider there are three numbers A, B, C. So then let me write like this: A into B into C is equal to A into B into C. Say for example, 2 into 3 into 4. What happens here? 4 3s are 12, 12 2s are 24. Right, here let us check out. So A is 2 here, B is 3 and C is 4. 2 3s are 6. 6 into 4, 24. This is associative property of a multiplication. Right. Properties of multiplication, identity element. So the product of 1 and any whole number is the whole number itself. If you multiply any number by 1, it is nothing but the whole number itself. Say for example, 3 into 1 is equal to 3. 5 into 1 is equal to 5. If you multiply any number by 1, which gives the number itself, that is identity element. Here 1 is the identity element. Let us check, right? One more, that is distributive property over addition. Here, suppose Let if A, B, C are any three whole numbers, then we can write like this. That is A into B plus C is nothing but A into B plus A into C. So a lot of problems will be asked based on this particular property. You need to be careful about it. You should apply this particular rule. Say let us check out 3 into 4 plus 7, which is nothing but, so you are going to multiply 3 into 4 plus 3 into 7. Answer will be same, you will get it. So let us check out 3 into 7 plus 4, 11. 11 3 is a 33. Now we will check out 4 3 is a 12 plus 7 3 is a 21. If you had, you are going to get 33 itself. This is a distributive property. It's very important property which we used to get the problems based on this particular property. Let us check out with the division. In case of division, it represent a repeated subtraction. That is, let us check this. 15 divided by 3 is equal to 5. Now, 15. If you continuously subtract 3 5 times, you are going to get this thing. What is that? 5 only. See, let us check this. See what happens here. Minus 3 is equal to 12. 12 minus 3 is equal to 9. 9 minus 3 is equal to 6. 6 minus 3 is equal to 3. 3 minus 3 is equal to 0. So see how many times you did? 1, 2, 3, 4, 5 times you subtracted. You are going to get the 0. So this is what the repeated subtraction. It's very simple. Let us understand one or two problem, one or two examples of division. Let us check. 195 divided by 95. So 195 that divided by 15, not 95, 15. How you are going to do? You know how to divide. So let us check out 19. 19 which is supposed to be less than. See, you are supposed to find the product. See, that is 15 ones are 15, right? 15 ones are 15. Subtract here. 9 minus 5 is 4, right? 1 minus 1 is 0. Right, now you bring down 5. 15, so 15, table you should know, 15 3s are, that is 45. See, 0. It is completely divided. So the answer, what happens, this is called as divisor, right? Divisor, and this is called as remainder, a remainder, and this is called as dividend, dividend, and this is called as quotient. A lot of problems will be there based on this, right? Let us check this. 391 divided by 23. 391 that divided by 391 that divided by 23. If you are not able to this thing, what is that? If you don't know the table, then what you can do? You can write down 23 ones are. So 23 twos are. So 3 twos are 6, 2 twos are 4, 46. So 23 threes are. So that is 3 threes are 9, 3 twos are 6, 69, 23 fours are. 4 threes are 12, 1 carry, 4 twos are 8 plus 1, 9, 92. Like that you can write down and work on it. See, now let me divide 391 by 23. 23 ones are how much? That is 23. So subtract now. 9 minus 3 is 6, right? So 3 minus 2 is 1. Correct? Right, 16. Now bring down 1 here. Now let us check out. So see, 23 fours are. See, let me go with the 23 fives are. So 23 6 are. Right, 5 3s are 15. 1 carry. 5 2s are 10 plus 1, 11. Right. So 6 3s are 18. 1 carry, 6 2s are 12 plus 1, 13. 138. 23 sevens are. 7 3s are 21. 1 2 carry, 7 2s are 14 plus 2 is 16. 161. You can stop here. That is 23 sevens are. See, 161. So 0 0 0. So here what it is called as? It is called as remainder. This is called as dividend, right? This is called as dividend, and this is what? The quotient, right? And this is 23 is what? It is divisor. The mean, there are three formulas will be there that you should remember. That is, one is dividend is equal to divisor into quotient plus remainder, right? And divisor is equal to dividend minus remainder divided by quotient. Quotient is equal to dividend minus remainder by divisor. These three formulas you should know it. Say for example, let us take this 1, 2, 3 that divided by 9. Let me check out. 9 is a divisor. 123 is a dividend, right? 9 ones are 9. 12 minus 1 is 12 minus 9 is 3, right? You bring down 3. 9 3s are 27, right? So that is going to be 6. Now 6 is a remainder. If you substitute here, you will get the answer. Let us check with this dividend. So now I need to find out dividend is equal to right, divisor. Divisor is how much? 9 here into what is quotient? Quotient is 13 plus what is remainder? Remainder 6. So 13 9s are 9 3s are 27, 7, 2 carry, 9 1s are 9 plus 2, 9 plus 2 11, 117 plus 6. So 7 plus 6 is 13, 1 carry, 11 plus 1 12, so 123. This is a dividend. Same way, if you apply these numbers here, so you can find divisor and as well as quotient also. So they won't give in the problem one or the other number, okay? So that you have to check out. So let me summarize, right? So you should remember this. The property or operation. For addition, the closure property, commutative and as well as associative property applies. For subtraction, no properties will be there, that is associative, closure and as well as commutative. For multiplication, again the three will be there, that is closure property also will be there, commutative and as well as associative. For division, no property will be there. So I think you understood. You properly understand the operations, because those operations are already you know. Only thing, applying those concepts what you learned for problem solving is what matters in most of the competitive exams. Okay.